Hi, and welcome to our first in this series of videos on vectors. And this video is just an introduction to the basics of vectors and what's going on with those. And so we're going to be looking at what a vector is. We're going to be looking at magnitude and direction, something called scalars, resultants, and then finally an application of something we refer to as the triangle law. So in this particular video, we're just going to have a look at, it's basically like kind of GCSE plus a bit, some new notation. Looking at what's going on with vectors. So here we go. Right, so what is a vector? Essentially, we need to understand the difference between a coordinate and a vector. A coordinate, as you know, in that kind of notation there, x, y coordinates identifies a position, whereas a vector, with this column notation, identifies a movement. So, for example, if I wanted to describe the coordinate 3, 2, relative to an origin, then clearly I've gone across 3 up to, and that's the position of that coordinate there. Whereas a vector, 3, 2, describes a movement that means I've moved across 3 and up to from where my starting point was. And that starting point can be absolutely anywhere on the grid. So if that vector there that you can see on the diagram is the vector 3, 2, then so is that one, and so is that one, and so is that one. So regardless of where we start, all of those are vectors of 3, 2, and they just represent exactly the same movement. Now, the new bit that you might not have seen at GCSE is our ability just to describe these slightly differently using what we refer to as unit vectors. And the unit vectors are this thing here. We're going to use I and J, and I is just a horizontal movement of 1 unit. So it's the vector 1, 0, so it's just moves across 1 unit. And as you might have guessed, that means that the vector J is just 1 unit vertically. What that means is if we've got a vector 3, 2, that's essentially 3 lots of I plus 2 lots of J. So this notation here, using this column notation, that is exactly the same as this notation here. 2 ways of describing exactly the same things, and sometimes you'll be working with column vectors, and sometimes it's easy to work with the unit vector notation. In addition to that, if we've got a vector that's moving from one point, so from A to B, we can describe that as either just the vector, in this case 4i minus 2j, we're just going to call it the letter A. Alternatively, we can just describe that as being the vector AB, with the arrow going on the top saying, okay, it's going from A to B. And again, that's 4i minus 2j. So all of these bits and pieces in here are just different notations, different ways of being able to describe a vector. And finally, if we've got the vector BA, so in this case we're going from B to A, you'll notice on the diagram I'm going from A to B, so I've got the arrow here giving me the direction I'm going in, and you'll notice that's occurring on all of these vectors here. I've all got these arrows on telling the direction. This one's going from A to B, so clearly B to A is the reverse of that. It would be the one going that way. And so, therefore, if AB is 4i minus 2j, to get from B to A, I'm going minus 4i plus 2j, so just basically reversing the signs here. So with the negative version of I, which is minus 4i plus 2j. Okay, so that's the basics. Moving on, we've got another couple of definitions just to go through. So we've got a vector quantity. Now, a vector, in any context, is a quantity that's got magnitude and direction. It's got those two things. It's got to have both things. So, in fact, you know how big it is, the movement, and what direction it's going in, as opposed to something that's a scalar quantity, which has just got size. And you'll see the difference between those two things when we go through a bit further into this slide. So there's our vector AB, and we can say, well, the magnitude of that vector is calculated using Pythagoras. So what we're going to do is say, well, if this vector goes across 4 and down 2, then that distance there, that size, the magnitude, is simply calculated using Pythagoras 4 squared plus 2 squared. And this notation here is technically called a modulus, but it's just kind of these straight lines just indicate that we're talking about the magnitude of the vector AB as opposed to the definition of AB, which would be the one with the arrow across the top. So we've got the magnitude of AB, which is 2 root 5 using Pythagoras. Now, we've got the direction that is given by the I and J components, or we can describe it as an angle relative to a particular direction. So looking at this here, we've got our triangle that's kind of 4, 2, that's what we use for Pythagoras. And so we could start calculating this angle in here, and that would be our direction relative to the I direction. So we're saying, okay, what is direction it's going in compared to the horizontal direction. So again, just simple quick bit of trig will give us that angle there. So we've got an angle of 26 degrees relative to the I direction, and we've got this negative bit here is because it's below the I direction, and we're going to find that, or you should already be aware that any angle measured in the clockwise direction that's going around this way is expressed as a negative. Anything going that way, anti-clockwise, would be positive. So because it's below the I direction, it's a negative angle, so we've got minus 26.6 degrees. On we go. The last thing we're going to talk about is something called the unit vector. So if we've got, let's say, a vector, I'm going to call it C, that's this vector here, minus 3i plus 4j. There it is, so minus 3i plus 4j. That thing has got a magnitude, using a bit of Pythagoras, it's got a magnitude of 5 units. And what we're going to say is the unit vector in that direction, and it's written kind of sometimes with this little kind of ticky arrow hat thing, whatever you want to call it, on the top, is the vector that goes in that direction, but is only 1 unit in length. So it's effectively, you can even remember that the unit vectors that are I and j in the horizontal and vertical directions. This is exactly the same concept, but in a particular direction according to this vector here. So essentially what we're going to want, if we want something going in this direction, and we know that C is 5 units long, we're going to need 1/5 of C. So 1/5 of C is going to be 1/5 of minus 3i plus 4j, because that's what C is. So the unit vector itself, and I've written it in column form here, is going to be minus 0.6, positive 0.8. And in general, we can say that if we've got a unit vector in a particular direction of the vector A, so we take our vector A, whatever vector this is, which would be essentially the equivalent of that bit there, and divide it by the magnitude of A, which is the kind of the 1/5 bit.